Chapter 9, Matrix and Determinant, Part 1. We have already discussed the basic concept of a matrix. For example, this is a given matrix. There are n rows and n columns. We will call this as n by n matrix. Each number inside the matrix, we will call this as an element. For example, this is one of the element A11, and this is another element AMN. There are several examples of a special matrix. For example, this one. We will call this as a row matrix because we have one row only. And this is column matrix, similarly, and this is called square matrix because the number of row and column are equal. So this is called a square matrix and order 3. So 3 by 3 square matrix. And this is zero matrix. If all the elements are 0, then we will call this a zero matrix. And one more special matrix you need to remember. You need to remember which is called unit matrix or identity matrix. All the element on the diagonal is equal to 1 and other is equal to 0. This is a unit matrix or identity matrix. We have already discussed that what is the meaning about two matrices are equal. If two matrices are equal, for example, this example 9.1, A is equal to B. That means they must have the same order and their corresponding element must be equal. That means this is 3, this is also equal to 3. So obviously I know A is equal to 1 because these two elements must be equal. And then 2 is equal to B and W is equal to 2W. So B is equal to 2 and W is equal to 2W. That means W is equal to 0. For exercise 1, maybe you can pause the video and then do it first. After that, you can continue to watch the example. I will illustrate how to find the values of A, B, C, X, Y, Z. 2A is equal to B. Maybe you need to know what is the meaning of 2A. 2A, that means 2 is a scalar and A is a matrix. If we need to simplify it, each element we need to multiply 2. So which is equal to 8, 2x, 0, 8, and 2z and 2y. This is equal to B. A plus 2, 3A, B, 2C, AC, and B minus C. And not very difficult to find A because I know A plus 2 is equal to 8, so A is equal to 6. And 2x is equal to 3A, that means it's equal to 18. 2x is, so you can also find x is equal to 9. And B is equal to 0. And C is equal to 4 because x is equal to 2c. And then 2z is equal to A times C. 24. Z is equal to 12. And last part, 2y is equal to B minus C. B is equal to 0. And C is equal to 4. So 2y is equal to 0 minus 4. Y is equal to negative 2. Then you have already found A, B, C, X, Y, and Z. Basic operation of matrix. In our previous video, you have already know how to find the matrix multiplication, but we haven't discussed how to find the addition and subtractions. Example 9.2. Not very difficult to find. What is the meaning about how to find the subtraction and addition? If you want to find, that means remember, if you want to do the subtraction and addition, the order of these two matrices must be equal. And then if they are the orders are not equal, we cannot do the addition and subtractions. And if you want to do the subtraction, that means the first element, the first row, first column element, subtract minus the first row, first column of the element of this matrix. So the answer is 3 minus negative 2, and negative 2 minus 0, and 6 minus 1, and 0 minus 5. So the final answer is 5, negative 2, 5, and negative 5. And you may do the following exercise 2 first, and then you can check the answer. So add the corresponding element together, and then you can find the value. So 0 plus 2 is 0 to 2, 1 plus negative 1, 0, and then 7, and the last one is 0 to 2. Next page. For the scalar multiplication, if we have one scalar, for example, this one is 3, and this is A. This is A is a matrix. How to do the multiplication? You need to multiply this 3 to each of the element, and then you can find the answer. 3A is equal to 3 times 3, and negative 2 times 3, 1 times 3, negative 2 times 3, 6 times 3, and 2 times 3. It's 9, negative 6, and 3, negative 6, 18, and then 6. And you may do the following exercise 3 first. Following exercise 3. Maybe you can do it directly. That means multiply 4 to this matrix and multiply negative 3 to this matrix, and then add one matrix and multiply negative 2. But this example, I want to illustrate. We have some property for the basic operation of matrix. For example, we can rearrange the order. Remember the multiplications. A times B is not equal to B times A in matrix. But for the addition, we can rearrange the order. They are equal. And then this is 4A plus A. We have another property. We can add them together first. 5A minus 5B. And maybe you don't want to multiply. We can also take out some scalar. So in this example, maybe you can find A minus B first. So it's 2, 0, and negative 1, and negative 2 times 5. So the final answer is 10, 0, negative 5, and negative 10. You may find the basic some property in the page. For example, A plus B is equal to B plus A. This is called commutative properties. A plus B plus C, we can add BC first or add AB first. This is called associative properties. This M we can distribute into the matrix, the distributive property, and then we can also, if this is M plus N, we can also multiply the matrix separately. And then if we have two scalar, we can calculate NA first or calculate MA first. They are equal. This is some property of the matrix. You may do example 9.5. I don't want to spend time to do it with you because not quite difficult. This example is similar to the previous one. Page 7. Multiplication of matrix. We have already discussed the multiplication of the matrix. Maybe you can turn to page 8 and then do some practice. Remember, A times C is not equal to C times A. So we have a special order. If A times C, A must be on the left-hand side and C must be on the right-hand side. And then you also remember, if you need to do the multiplication, the order, we have some special requirement. And then Although we cannot change the order. For example, A times C is not equal to C times A, but we still have associative property. That means A times B times C, we can do A times B first, or B times C first. But for the distributive property, if A on the left hand side, if you distribute into the bracket, if A, B, C are matrix, A must be on the left hand side. So we have two distributive property. If C on the left hand side, if we distribute into the matrix, C must be still on the left right hand side. You may turn to page 9 and do follow-up exercise 7. This is the first part of the video, which is related to the basic concept of matrix and the operation. Remember, you need to know how to do some operation. In part B, we'll discuss the determinant. We have already discussed how to find the determinant and the inverse. I will pinpoint some special technique on the determinant, how to find the determinant, or how to simplify the determinant, or how to find the determinant in other way.